Hello, my name is Derek from Tomcat Gas Training, and the video you're about to watch is about this flue gas analyzer. So we're going to be looking at the safe use and the correct use of flue gas analyzers. Now, to understand your flue gas analyzer is incredibly important, and you must always read the manufacturer's instructions on how to use your analyzer, no matter what analyzer you're using. Also, we have BS 7967 2015 to aid us in the correct use of the analyzer. So in this video, what we're going to be doing is how to use them and how to understand the results we get. So, as usual, let's get on with it. Okay, so we're going to look at this little tip, what we can do just to prove that we've got no air leaks in our hose, gun, or in the trap, the bowl trap on the analyzer. So I'm just going to stick the analyzer on this boiler because of the magnets on the back. Now, this is where we sample. So you could actually put a tight fitting tube on there and bend the tube over as long as you know it's tight fitting. But if it isn't tight fitting, another way you could do it is you can block off here and make sure you have to block the end off as well. And what we should get is an alarm. The pump should go and we should get an alarm from the analyzer to tell us we've got no airflow. Okay, and that's going to prove you've got no leaks whatsoever in your pipe, your bowl, and the connection going to the analyzer. And you should always do this when you suspect that you're getting wrong or incorrect readings. So if I put my fingers over the end of there and block the end up, you can now see it's put a warning sign on the analyzer to show it says there's a blockage detected. Okay, just going to press escape and it's back working again. And that's proved to me that there is no air being drawn into this analyzer from a broken bowl, broken seals, or a broken probe. So let's start using this analyzer. Now what we've got here is we've got the Ariston boiler. Our test points are at the top. There's a little screw that holds in there which I've already pulled off. Now we have two sample points. One which is on the left hand side, which is our analyzer out, so products combustion out. And the one on the right hand side is our flue integrity testing, which we'll look at in a minute, which is sampling the air coming in. Now the easiest way to tell them, if you just get your probe and slide it in, if it goes in at 150 mil, between 100 and 150 mil, that is your flue gas analyzer port. And if it only just about goes in, so maybe 30-40 mil, then that's your flue integrity port. Let's talk about the probe. Now the probe is 200 mil long. Now if I was to sample the flue from the outside, I would use the full 200 mil into the flue way. That will stop you drawing air in. So always remember, if you're analysing from the outside, is always slide it in. But when you're analysing from this port on the inside, you want it set for about 150 mil because you don't want to be drawing all that water or that moisture into the analyzer unit. I know we have a bowl to stop that, but we don't really want to start sucking all that moisture in. So the depth gauge is important, and it also makes a seal. So make sure you set it for about 150 mil. You then slide it in. There you go, that's fully in the sample point. Now, I've not got the boiler on full power. I've just got it running. It's actually on minimum setting according to the gauge at the front because we've got the heating running. So this is doing our minimum setting. Now what I'm doing now on minimum, I'm just waiting for it to stabilize. So I could have up to 15 minutes waiting, but if I get a stable reading within the 15 minutes, then I can deem it okay. So at the moment, we've got an O2 of 5.7, a CO of 8, and a CO2 of 8.7, and a ratio of 0.0001. Okay, so we've got very low CO. We've got CO2, which is round about right, 8.6, and then the ratio is well in 0.000. There's 3 noughts and then 1. Okay, remember we could go down to 2 noughts full. What I'm going to do now is I'm going to put the boiler into high fire. I'm going to leave the analyzer in there, and then let's see what happens. Now, it takes, because of the length of the tube, it takes about 10 seconds. So you need to allow about 10 seconds when you're taking your second reading, just to allow the products of combustion to go through the tube, through the trap, and then into the actual analyzer. So don't be quick to adjust things. And if you are adjusting the zero governor, you've still got to do a little tiny turn and then wait at least 10 seconds before you start turning it again. Now you can see our oxygen reading is 5, our CO has shot up to 92, our CO2 is 9.1, and our ratio is 0.0010. We're still on maximum, but the figures are still changing. Remember, 15 are stable reading. At the moment, I'm getting a CO2 of 5.2. We're getting a CO of 87, and our CO2 is 9. Our ratio has now gone to 0.001. So you see, I didn't just automatically just took the reading, yeah, that's the one and that's it. Okay, you've got to leave it to stabilise. Now we've got a reading of O2 4.9, CO 97, CO2 9.1, and again the ratio of 0.0011 this time. And that seems now to be pretty stable. Okay, so that is what we've got on this appliance. So what we would do now is we would check our CO and our CO2 with the manufacturer if they give us those figures, or we're looking at the ratio to make sure it's less than 0.004. Okay, so far this boiler on minimum and maximum seems to be pretty good. The next test I'm going to be doing, so the flue integrity test. What this is going to do is it's going to tell me whether our seals are broken within the flue, whether it's on the top of the turret, whether it's in the flue, or even whether the actual terminal is broken as well. So what I've got to do with this analyzer now is change the screen. So what I'm going to do now is I'm just going to slide that in to the right hand port now, not the left hand, the right hand port. I'm just going to leave it. I've got my settings on minimum, and I'm just going to leave it again for 15 to 30, or whether I get a stable reading. Now the results we're looking for on this are our oxygen levels of greater than 20.6 or equal to or greater, and our CO2 levels of equal to or less than 0.2 and no ratio. Because if we've got a high CO2 and a ratio, that means our seals are probably gone. Now another way of checking whether your seals have gone is if you're inside your boilers full of water and rust, because that's, if it's rusty water and rusty casing, that's a good chance it is flue water, because it's acidic, where central heating water wouldn't be acidic. So what I'm doing now is I'm just leaving it again to stabilise. At the moment I've got an oxygen reading of 20.5, but I've got a CO reading of 4, I've got a CO2 of nothing, ratio of nothing, NOx air of nothing, flue temperature of 32 degrees, no efficiency, and a pressure of 0.48. So if I started taking that reading now, I would be panicking. But I can see already my CO has gone right the way down. My oxygen readings are 20.6, and this is why it's so important that we leave it for that time, because again it takes 10 seconds for it to clear. So now I've got an O2 of 20.6, a CO of 3, well, it's just gone down to 20.5 now, and a CO of 3, and no CO2 at all, no ratio. Again, our CO's dropped down to 1, and again our oxygen level has gone up to 20.6. Now, because my oxygen level, well, it is 20.6 at the moment, is quite low, what I need to do is flue gas analyse through the window on the same wall of where this flue is. So I'm sampling the oxygen outside, because you might not have 20.6 oxygen outside, but because I've got a very low CO and I've got no CO2, then that's probably going to be an indication that we have got low oxygen O2 outside. And I know here where we are in the centre of Ashton, we always get between 20.4 and 20.5 oxygen, always. Summer, winter, whatever, we always get around about that reading. So I'm not worried by the results from this boiler. So that's flue integrity on low. We now need to do the flue integrity on high, so I'm going to put it on high again. And again, I'm going to leave it. I'm not going to stand there staring like that, panicking, because what's the point? If you've got a poor reading, you'll get a poor reading in 5 minutes or 15 or 20. If you've got a good reading, we need to wait that time. So now I'm on high, straight away, I'm on 20.6. We've got a CO of 1, we've got no CO2, we've got no ratio, we've got a flue temperature now of 31 degrees, and that's pretty much what we've got. We've now got no CO, so that's pretty much about as stable as we're going to get. Remember, if it's a non-condensing boiler, you would be looking for a ratio of 0.008. Non-condensing boilers weren't designed to be analysed. Flue gas analysing only came in because of condensing boilers. You won't know what your CO is, won't know what your CO2 is, because the manufacturer will never have given you those readings. But you'll always find a non-condensing boiler, so say a balanced flue boiler, will give you very low CO readings because it's not that efficient. So that's flue gas analysing the condensing combi boiler, or any condensing boiler. It doesn't have to be a combi, it could be a regular or a system. Now, we've finished doing our analysing, but what I'm going to do is I'm going to take the probe out, I'm going to come out of test mode, because we don't need it in test mode now, and I'm going to move my analyser away from the boiler. I'm just going to stick it on this one, and I'm just going to hang the probe, still with the pump running, on the side of this boiler, while I put my sample points back in. Now, my sample points back in, let's bring back the analyser. What I've done is, I've left it on, and our oxygen reading now is reading 20.6. Our CO is 0, CO2 0, no ratio. But I want my oxygen levels to go up a little bit, because then I know I've completely cleared my sensor. Because when I turned it on, I had 20.9 oxygen. Now, once we're happy with the oxygen levels, we know it's not contaminated now. I've got no CO, I've got no CO2, and I've got no ratio. Because the next test I'm going to do is I'm going to do a sweep test. I'm now going to test around the outside of the boiler. Okay, I'm going to test the turret, I'm going to test the sample point, I'm going to test the case seals of this boiler. Okay, and I'm looking for a CO reading of less than 10 parts per million. Now, if I've got a CO of more than 3 parts per million, I might need to start investigating, because I could actually have left the test point off the top. Now, when we do this with the trainees and we leave the test point off, we always get readings of around about 3, 4 rather than 10, because obviously it's only a 2-minute test. We're not leaving it on long enough to get the air vitiated. So if you do get a reading of greater than 3 parts per million when you do your sweep test at the end, check your test point. So it's dead straightforward now. Still got the sample probe. All I've got to do is press the middle button, and I can now start sampling. Or I would start now analysing with this boiler in maximum setting. I start at the top, going around the flue, going around the turret, going around the sample point, going round the case seals of the boiler. So remember, this is a 2-minute test. Again, always remembering it takes 10 seconds for get from there to inside there. So we're going 1 minute and 17 seconds now, and we have no readings. We've got no CO, we've got no readings whatsoever, so we've not actually got anything. Let's round the sample point. Remember, hold it there for 10 seconds. You can even use the clock on the front. So when this gets to 2 minutes, it will tell me. So it's now got to 2 minutes, it's now told me. And again, wait that 10 seconds. I can now press the middle button and I can say it's passed. We got nothing. We got no CO whatsoever coming into this room. So we can deem this safe. We've left it safe. Not a lot of engineers do the sweep test, but if I was you, I would do the sweep test as your last test, and you'll never ever forget to put the sample point on. Hopefully. Now this is the Flula space heater we're going to be flue gas analysing. Now you don't just want to be racking up to a Flula space heater and flue gas analysing it and jogging on. that is not what we've got to do. First of all, the regulations state that we can't service, repair, commission, install a gas appliance unless we have the manufacturer's instructions. Now with Flula space heaters, the manufacturer's instructions are really important because they're not all the same. So having the manufacturer's instructions is number one important. Now number two, we must do a visual inspection before we flue gas analysing this appliance. Now things we've got to be looking out for is, first of all, the size of the room. Is this room big enough for this appliance to go into there? Now according to the manufacturer's instructions, it says this cannot be installed in a room less than 30 meters cubed. But there is a formula to help us with this, and we'll have a look at that in a minute. Now, next consideration is it requires ventilation, permanent ventilation. And this permanent ventilation has to be 100 centimeters squared of free air up to 2.7 kilowatts if it's installed in a room. And it should be installed in a living room, okay? Now, it can't be installed in a shower room, it can't be installed in a bathroom, it definitely can't be installed in a bedroom. So siting considerations always needs to be taken into account. So this vent, 100 centimeters squared, has to be at least a meter away from the appliance. And that is to stop the pilot, the ASD, staying on. Okay, so that's why it's important it has to be a meter away. Even though the manufacturer's instructions in this book says it only needs to be 500 away, but now it needs to be at least a meter away. Okay, now this vent also can't be behind radiators, it definitely can't be behind furniture or curtains, but you've got to take into consideration whether the cold air is going to cause problems. So always site them high up, and obviously they've got to go on an outside wall. So other considerations are, this cannot be installed in a room without a primary source of heat. So what do we mean by a primary source of heat? Well, basically radiators. Okay, so it can't be a standalone heater. There has to be another way of heating the room, so you're not running it all the time. Also, all flueless appliances require an openable window. Now, a flueless space heater fails its flue gas analyzer readings, it's ID. The ventilation requirements for this, if they're wrong, at risk. But if it fails its flue gas analyzer readings, it becomes ID. So these are the considerations we've got to be looking at before we even attempt to flue gas analyse this appliance. Now let's have a look at this fire in a little bit more detail. Now I've removed the outer casing. So basically what we've got here is a glass front. The reason for the glass front is to actually send the products to combustion through the catalytic converter. So this is the catalytic converter here, and it's also to reflect the heat out. So that's what the glass does on the fire. So again, the seals, according to the manufacturer, we must check the seals are intact when we come to service it. Remember, gas appliance needs to be serviced every 12 months. Now, catalytic converter, what does that do? Well, basically what it does is it converts the CO from the gas back into CO2 and water vapour by scrubbing it and adding oxygen, basically. So that's basically what it's doing. Now, you hear loads of stories about catalytic converters. They don't last very long. Now, they've done ongoing research, most of the manufacturers, for these catalytic converters, and they will say they will last between 27 and 30 years. But that's if it's running no less than 16,957 hours in its life, so about 17,000 hours in its lifetime, and they've worked that on 4 hours a day, 7 days a week for 5 months a year. So that's what they've been looking at, but obviously manufacturer's instructions will tell you how long these catalytic converters will last. Now, according to the manufacturer's instructions, there are 2 tests we need to carry out. It's written down here in black and white. It says the first test we need to do is the CO-CO2 ratio test, and then the second test we're going to do is the room CO2 test. So we're just going to concentrate on testing the appliance first. Now, it also says, we don't use this, so BS 7967 says we don't use this sample probe for flueless, we use this sample probe. So this is the L-shaped 5-hole sample probe. Now I've got the analyzer running. It's actually reading an oxygen level of 20.1 I don't know whether you can see that. CO of 0, CO2 nothing, ratio nothing. Okay. Now I'm lucky here, I've got a metal fire surround, so I'm just going to stick it to my metal fire. No, I'm going to be able to see it there. I'll stick it here. Hopefully we'll be able to see that. Now, what the manufacturer says, using the 5-hole sample probe, it says to sample across the top of the outlet, but not touching. Okay. Now, it also says to run the fire for 15 minutes beforehand and no more than 30 minutes. So this has been running for about 15 minutes now. So what it says is to sample across the top here. And it says not to touch, just to keep sweeping backwards and forwards until we get a stable reading or we get our lowest O2 reading. Okay, so our lowest oxygen reading or our highest CO reading. Now, we shouldn't get much CO coming out of this because it's supposed to be converting that CO into CO2. It also says we can't have a ratio of more than 0.001. Remember guys, it fails this test, it will automatically make it ID. So at the moment we've got an O2 of 18.3, a CO of 0, a CO2 1.8, and a ratio of 0.0000. Now we've been flue gas analysing this for quite a while now, and our ratio is not going off 0, but our CO2 levels keep going up and down, and our lowest oxygen reading so far I've had is about 18.6, so that's our lowest oxygen reading. It's getting off, it's getting quite hot here now, it's getting pretty damn hot. So the oxygen levels are going back up, our CO2 readings are all over the place, they've gone down again now, and I'm just literally doing what the manufacturer tells me to do. So I think we can pretty much say this is our final reading. So our final reading, got an O2 gone down to 17.9, 17.8. We've got a CO of 0, we've got a CO2 1.9, and again with no ratio. So we can pretty much say this is passed. As I've just said, next appliance we're going to look at is this, a cooker. Now, flue gas analysing a cooker is different than a boiler or a flue, a space heater in a couple of ways. First of all, flue gas analysing the hobs. Can't do it. So basically what it says is, check the flame picture. Okay, so is the flame picture good? Try the flame picture on high, and does it stay lit on low? And that's basically what it says to do. Just check the 4 flame pictures. So the first thing we're going to do is the grill. Now, according to the British standards, manufacturer's instructions, we're using this 7-hole probe. Okay, so first of all we need to change it from this one to this one. And basically what it says to do is rest it on the top there. Okay, so we're going to get the grill on. Okay, we're going to get the analyzer on. We're going to leave this, we're going to run it. But I'm going to start analysing it as soon as I turn it on so we can have a look at a few readings. So first of all, let's get the analyzer turned on in fresh air. As you can hear, the analyzer is now on. So first thing I'm going to do is I'm going to turn the high level grill on, and I'm going to put it on maximum, and it's lit. It does say when you're doing this test to have the grill pan in, and the grill pan has to be at its highest level. Well, this one can only go at one level, so we've still got it in. So that's got to be in position. That's the first thing. I'm going to put that through on the where the flue is on the top here. So this is where the products of combustion are exiting the grill. And I'm going to start analysing. I've just instantly turned it on now. You can see the readings are getting O2 19.3. We're getting a CO 46. We're getting a CO2 of 1. And we're getting a ratio of 0.0047. The reason why the ratio is red because it thinks it's a boiler. So that's the readings we got instantly as we turned it on. And it's a CO we're interested in. Remember, this can't go over 90 parts per million. And it has to get below that 30. This cooker is making more than 30 parts per million. But I've only just turned it on, and we shouldn't really be analysing when we first turn it on. We should be at least waiting 5 minutes. This can actually make 90 parts per million first, but it must start going below 30. But now it's great, it's gone down below 30 already. Okay, it's now, we've got an O2 of 19.4, we've got a CO of 26, we've got a ratio of 0.0026 because we've got a CO of 1. But that's just me just turning it straight on. Now, according to my little chart here, if we've got a flueless cooker, which this cooker is, and we've got an oven, which we have, our ratio has to be lower than 0.008. Now, the whole bit just says like we've done. I'll check the flame picture. Now, if we've got a cooker grill, which we've got here, and it says it's CE kite mark, or it's got a gas council number, a GC number, then it's 0.010. So if the cooker has no CE kite mark or has no GC number, then it's 0.020. So that's what we're looking for a ratio. Now, this does not have a GC number and does not have a CE kite mark or a British standard or anything like that. So we're looking for a ratio of 0.020 less than. And at the moment we've got 0.0016. So we're well in with both of those readings, whether it's got a CE kite mark or it hasn't. So I've been analysing this for more than 15 minutes, and I've now got O2 of 17.9, the CO of 26, the CO2 of 1.7, and a ratio of 0.0015. And that is after 15 minutes. Now, been analysing it quite a long time now. It's getting pretty hot stood here. Okay. Now, again, before we do these checks, it says windows and doors have to be closed, but the ventilation, if this permanent ventilation, needs to be unobstructed. So that's basically what it's saying for the cooker. So if your room or your kitchen is less than 10 meters cubed and you haven't got a back door, then you're going to be needing ventilation. Okay, so if your room size was 0 to 5 meters cubed, you'd need 100 centimeters squared. If it's 5 to 10 without a back door and an openable window, you'd be needing 50. But if you had a back door going direct to outside, or patio doors or something like that, then you wouldn't require permanent ventilation. And if your room is greater than 10 meters cubed, then, or your kitchen, you wouldn't require ventilation. Obviously, unless the manufacturers tell you to. So, I've been doing this now way over the 15 minutes, and my CO reading is fluctuating between 28 and 30, and my ratio is way down to 0.0015. So my ratio's in there and my CO levels are kind of on the borderline. Okay, so that is analysing the grill. Okay, let's have a look at the oven. So we're going to do the oven. So first thing we need to do is turn the oven on. Main oven, going to put it on to maximum, light it. Now the oven should light in low rate on this one because it's a liquid vapour, and then it should go on to high rate. Now So I'm just going to wait for that. And again, we're supposed to be letting this run for at least 5 minutes first. This time I'm going to be using the 5-hole sample probe, and this is where the products of combustion will come out of this cooker. So you need to understand and know from the manufacturer's instructions where these products would come out. Now this has just gone up to high fire. I can now feel the heat coming out of there, and I'm just going to place the probe in the flue way. The probe's now in the flue way, and I can now monitor the readings what we've got. So you can see we have an O2 of 18.3, a CO of 4, a CO2 of 1.6, and a ratio of 0.003, and that's literally, we've just turned it on. Okay, now again, according to my little chart for a oven, so we need 0.008 as a ratio. So again, this is literally just turned on. So according to these readings, it is still well under. Okay, so we'll just leave it for the 15 minutes and let's check back. Let's see what it gets up to as a maximum. And now we've got an O2 of 17.4, we've got a CO of 7, we've got a CO2 of 2, we've got a ratio of 0.003, and that has been going on now for about 20 minutes. Now when you're flue gas analysing an open flued appliance, we can't be going drilling holes in the top of the flue and putting our probe in there. Oh no, because you just made the flue ID if products of combustion are coming out, because you've just broken the integrity of the flue. So you do not drill holes in this flue, okay? And if there is a hole in the flue, someone's put some tape over it, because it should be twin wall flue system coming off the top of an open flue boiler. This is a training centre, this is the wrong flue system. So if you've got single wall, that makes it at risk. And if you've got damaged flue with a hole in it, it's at risk. And if products of combustion are coming out of it, it's ID, okay? So never drill a hole in the flue for a flue gas analyzer test port. Because what you're supposed to do is take your probe, and you can actually get some extension pieces. I have got an extension piece here, or you can have it made, but you have to slide it up the flue, and so you're inside here, and you're sampling up the back of the draft diverter. Okay, so you come in at the back of the draft diverter, find the flue hole. There you go, I'm in. So I'm now in the flue ways, and it says to be about 100 mil into the flue way. Okay, and my hand is still down at the bottom. So if this was in a compartment, you would have to have the door of the compartment shut as well when you're flue gas analysing it. So open flued appliances, you'll be flue gas analysing this on maximum, because there ain't no minimum setting, and you'll be looking for a ratio of less than 0.008. And if you didn't get that, you'll be at risking it, stripping it, cleaning it, whatever we would need to do to get that ratio down. But the main problems we find with open fluid appliances, people drill holes into the flue system to take the sample. No, up the back of the draft diverter. Let's have a look at fires. Now, when we come to a radiant fire to flue gas analyse, there's nowhere to do it. Okay, so we can't flue gas analyse a radiant fire unless you're going to get on the roof and do it from the chimney, because there's no way of getting a probe inside. These weren't designed for flue gas analysing. But sweep testing, we should still be sweep testing around the appliance. Remember, 100 mil away from the appliance and sweeping around the appliance for that 2-minute test. Also, the open fluid boiler behind me, sweep test on that as well. Taking in particular care around the draft diverter. So it says sweep around the bottom of the draft diverter, okay, and around any seals where you would take away, you would remove for servicing. So this fire, no flue gas analysing on this one, but we can do the sweep test. So let's have a look at an inset live fuel effect. When you're flue gas analysing the inset live fuel effect fire, it says to put the probe into the flue this way. Obviously the fire needs to be running. I'm not putting the fire on because I'll be burning my hand, but you need again the extension probe to be able to be like here, but you have to get right in 100mm through the spigot hole at the back here, so underneath there, so it needs to go right the way in. So obviously I'll be getting burnt now if I have this on. So again, you need the extension probe to be able to analyse this fire. Now the ratios we're looking for this fire is 0.02, or unless the manufacturers give you an actual reading, which I doubt because they weren't made for analysing. So that's what we're looking for, 0.02, and that's your CO-CO2 ratio. But again, sweep test afterwards, it says 100mm in front of the fire. Okay, so that's flue gas analysing the inset live fuel effect fire. Now this is the boiler. We're going to be changing the zero governor. This is the Ariston E-Combi 1. Now first thing I've done is I've got my TPI SP620 manometer connected, and it's connected to my iPad. So it's showing our pressure at the moment is 23.25 millibars. That's on the inlet test point. So I'm going to be checking to see whether I'm getting the right pressures when I've actually got this on maximum reading. That's going to be checking that while we're doing it. Now according to Ariston, we're allowed an inlet pressure of 17.5 millibars. So first thing I need to do is remove the test point. So I've removed the test point off the top now. Next thing I need to do is get the analyzer turned on in fresh air. Now the analyzer is turned on and you can see it's reading 20.9 and everything else is 0. So I know this is ready to go. Now first thing I need to do is I need to get this boiler on, and I need to put it in high mode on this boiler, so high and low. So we're going to check the CO-CO2, the ratio in high and low, and adjust it if we need to. Now this boiler has a sit gas valve. Okay, so it has two connections on the gas valve. It has what's called an offset, which is here. So this big one here is the offset, and it also has a throttle. Now the big one here, the offset, adjusts the minimum setting, and the throttle adjusts the maximum setting. So what it's doing is it's adjusting the gas flow basically. So what I'm going to do now is I need to turn this boiler on and leave it running for a little while. It has been running for quite a bit today, so I've just turned it off so I can do this. Okay, so the boiler's now lit, it's now got in high setting. So, like I say, my probe, 150. Point, okay, and that's now going to sample. Now I need to get a steady reading. If I don't get a steady reading, I won't be able to adjust this. Okay, so at the moment I've got a CO of 29, CO2 of 75, and a ratio of 0.0005. So with my digital manometer connected, I've got an inlet working pressure of 19.98 millibars. This manometer is amazing. Okay, this has been loaned to us by TPI, so I'm going to be doing a full video on it, so we'll talk about that later. But what a great gadget, as long as you've got an iPad. You could actually use it on your phone, but I'm using my phone for filming, so as well as doing other stuff. So at the moment that's what it's showing, plus it's got this big screen, so hopefully you can see that. So we've got 19.95, we've got it on maximum. So that's the first thumbs up. We've got more than 17.5 millibars. So that's a good start. Now our settings, we have an O2 of 5.7, a CO of 59, a CO2 of 8.6, and a ratio of 0.0007. Okay, now on maximum settings, the manufacturer says we can have between 8.7 and 9.7 on the CO2, and at the moment we've got bang on 8.7. Okay, Now, some manufacturers will tell you to adjust the minimum first, and some tell you to adjust the maximum first, but you should always follow your manufacturer's instructions. Now, on the Ariston manufacturer's instructions, it puts the maximum first in the book, but doesn't actually tell you to do the maximum or minimum first. But anyway, some of the manufacturers do. So we require one of these. Okay. So basically, we've got an Allen key. Okay. So on this side here, we've got a 2.5 milli Allen key, and on this side here, we've got a 4 milli Allen key. Okay. Now we're going to be adjusting the throttle. Now, if I want to increase my CO2 reading, I need to turn it anti-clockwise, and if I want to decrease it, I want to turn it clockwise. Okay, but again, check the manufacturer's instructions. So at the moment, I've got a CO2 of 8.7. If I go onto the throttle, I put in my smaller Allen key in, if I can see it. Okay, I now want to increase it. So I'm going to increase it by turning it anti-clockwise. So I'm just going to turn it anti-clockwise now. So I've got to make small adjustments, and I've got to wait. The manufacturer says a minute, but remember it takes 10 seconds for it to come from the probe into the analyzer. So they say wait a minute. So I've just made a tiny little movement to the anti-clockwise, and it's now gone up to 9.1. Okay. So what I'm going to do is I'm going to make a little adjustment back again and get it back to 8.7 or around about that. So it's just a little movement, a little twist, and now I've got to wait now and see what it's going to do. So again, got to wait that. It says wait a minute. So it's now gone down to 9 from 9.1. Again, I'm going to try and get it back to the 8.7. We're still on, oh no, we've gone down to 8.8. Now what it says is, a little full turn going all the way around will adjust it about 0.2% on the CO2. But I'm doing little tiny turns. Okay, we're on 8.8, need to make that little adjustment again. So hopefully now this will be back to 8.7. But I could have actually left it where it was at 8.8. 8.7 to 9.7 we've got on maximum. So it's on 8.8. Okay? So I'm going to leave it there. So now what we've got is, we've got an O2 of 54, we've got a CO of 66, and we've got a CO2 of 8.8 with a ratio of 0.008. So that's our maximum adjustments. Now on our inlet pressure, 20.1 millibars, so that's perfect. Okay, they must be checking your inlet pressures as well while you're doing this. So we've got perfect inlet pressure, and we've got the readings we require on maximum. Okay, so now I'm going to put it on minimum and I'll look at those readings. Now this time we're going to do the actual offset, so I need to take off the dust cover first. So there's a little chrome dust cover on here, and again we're using the 4 milli Allen key. Now this is the opposite way to the last one, so if I want to increase it I have to turn it clockwise, and if I want to decrease it I turn it anti-clockwise. Now for this one, for minimum, we're looking at 8.4 to 9.4. Okay, so that's your CO2. Now we've got at the moment 8.9. Okay, we've got a CO of 5 and a ratio of 0.0001. So those readings, according to the manufacturer, again, are perfect. Okay, but if I wanted to reduce it a little bit, I could put my Allen key in and twist it a little tiny little bit. Let's see what that does. So I have turned it anti-clockwise, so it should decrease it from 8.9. Okay, Now remember, this is for natural gas. If I was doing this for LPG, I would have to set the valve up for LPG. It would be completely different. Okay, so always read the manufacturer's instructions. So it's now gone down to 8.8. Now go back up to 8.9. So we've got an O2 of 5.4, a CO of 4, a CO2 of 8.8 to 8.9. It keeps flickering. And our inlet pressure, we've got 22.45. So it is actually on, but it's on minimum. So everything seems to be ticky-to-boo at the moment. But I'll just adjust that a little bit. Just a tiny little turn. Now it's gone down to 8.8. Now remember, the manufacturer says wait a minute, but again it takes 10 seconds to get down there. Okay, so we could actually go down to 8.4. I'm going to give it a bit of a twist. So we're down to 8.7 now. So we've got, so again on minimum, we've got an O2 of 5.6, a CO of 4, a CO2 of 8.7, and 0 ratio. So that's our minimum, but now, because we've adjusted the minimum, we need to now check it back in maximum again. Okay, so let's see what's happened in the maximum reading. So I'm going to put this back in maximum, and let's see what the readings come out for that. Now again, I need it to stabilise. So at the moment we're on maximum setting for the second time, checking that. We've got a O2 of 5.5, we've got a CO of 53, we've got a CO2 back to the 8.8 what we had before, and we've got a ratio of 0.0006. Okay, so it looks like everything stayed pretty much the same. Remember, we've got this 8.7 to 9.7 for the CO2 on maximum. We've got a pretty low CO, haven't we, of only 52. So, crank it back up to 9 if I wanted to. But that gives you some idea now of how we're adjusting it and how long it takes to adjust it. Our inlet pressure, we've got this on maximum and our inlet pressure is 20.11. Okay, so we know that's fine. We know now our target pressures are working fine. We know now our flue gas analysing is at the moment coming in now at O2 of 5.5, we've got a CO of 53, we've got a CO2 of 8.8, and we've got a ratio of 0.0006. So that's adjusting a 0 governor. Now that is the end of this video on flue gas analysers, how to use them and how to understand the results. Now if you've liked this video, why don't you give us a thumbs up, because it shows me you care. Or why don't you hit that notification bell and subscribe if you haven't subscribed, because we release videos every Wednesday. So thanks for listening, thanks for watching, and if you want to watch any of the other videos, why don't you click on the links above. Cheers guys!